meaning, and complexification. If energy, information, and structural order are indeed all related, then we should expect to see a clear correlation between these measures in a complexifying universe. As entities move further from equilibrium, they should require more energy to sustain their informational richness and organizational depth. That is, we should expect to find greater energy flows per increasing measure of structural complexity. And indeed, this is precisely what the calculations reveal. In his book Cosmic Evolution: The Rise of Complexity in Nature, physicist Chaisson charts the universe's trajectory toward greater complexity by mapping these interrelated measures across big history. In full accordance with the second law, he writes, "The growing departure from thermodynamic equilibrium allows the cosmos to produce increasing amounts of net entropy and macroscopic information. We thereby have a means to appreciate in the main, if perhaps not yet to understand the particulars, the observed rise in complexity throughout the eons of cosmic evolution. From an initial state of homogeneity soon after the Big Bang, the universe began to self-organize and complexify." Chaisson's graphs all show a cosmos moving further from equilibrium, with entities of increasing free energy rate density and informational richness over time. Indeed, using free energy rate density calculations alone, Chaisson charts a clear trend toward complexification from matter to plant life to animals to culture. Citing some key figures in a 2014 article, he summarizes, "Among physical systems, stars and galaxies generally have energy rate densities that are among the lowest of organized structures. For plant life on Earth, energy rate densities are well higher than those of normal stars and typical galaxies. Likewise, as animals evolved from fish and amphibians to reptiles, mammals, and birds, their own energy rate density values rose still more. Not surprisingly, brains have among the highest values of energy rate density for all living things. Social evolution can be tracked, again in terms of normalized energy consumption, for a variety of human-related cultural advances among our ancestral forebearers, from early agriculturists to modern technologists. The number continues to increase. Such energy density increases correspond to increasing informational richness. Indeed, Chaisson writes, "To us, information basically is a form of energy. Thus, as the universe evolves more complex entities, more and more information is being generated, including the semantic information for those entities in context. Because increasing energy density and structural complexity are cause for ever-increasing semantic information processing, Azarian calls cosmic complexification itself a learning process." He says, "By now we can see a simple story emerging. By reducing Shannon entropy or ignorance, life is able to extract the energy it needs to reduce Boltzmann entropy or disorder. The growth of knowledge and the spread of organized complexity therefore go hand in hand. The second law is the impetus for learning." Learning thus appears to be the natural consequence and driver of a complexifying universe, as more energetically dense entities emerge to embody and encode more information about their environments. In this process, the very means by which information gets processed complexifies, with novel computational mechanisms emerging out of earlier ones to process new kinds of information. As physicist and quantum computing theorist Seth Lloyd expresses it, "The history of the universe in terms of information processing revolutions, each arising naturally from the previous one, already hints at why a computing universe necessarily gives rise to complexity. In fact, we can prove mathematically that a universe that computes must, with high probability, give rise to a stream of ever more complex structures." If increasingly complex entities in context are processing more and more semantic information to maintain themselves in the face of entropy, then we must conclude that meaning itself has been complexifying through time. But what does this actually mean? Is meaning really growing more intricate, refined, nuanced, rich, deep, sophisticated? What does high complexity meaning look like compared to less complex meaning? To unpack this idea, we must examine these successive information processing revolutions that Lloyd refers to, which have punctuated the complexification of the universe, such as marks the transition from matter to life. We must follow the arc of cosmic complexification and identify just what entities are processing what sorts of meaningful knowledge in a manner that maximizes their viability, and how this leads to qualitatively deeper forms of meaning. The Unified Theory of Knowledge, or UTOK, is a big history framework that offers perhaps the best map of cosmic complexification to date. It was developed by Gregg Henriques, a professor of psychology at James Madison University, with the intent to properly situate psychological phenomenon within the context of natural sciences and evolutionary history. In the process, it has helped clarify not only the field of psychology, but emergent evolutionary history more broadly, presenting a convincing meta-theoretical synthesis of different scientific disciplines that all tell one coherent narrative of cosmic complexification. Two components of the framework specifically, the Tree of Knowledge diagram and the Periodic Table of Behavior chart, bring a special clarity to the way information processing by thermodynamic entities in their respective environments has led to a universe of stratified behavioral patterns constituting genuinely novel planes of existence. As Henriques notes in his 2023 book on the UTOK framework, A New Synthesis for Solving the Problem of Psychology, quote, "The emergence of information theory, information science, chaos and complexity sciences, and philosophical analyses of living and mental creatures all show why a strong physical reductionism or eliminative materialism is a fallacious frame for scientific knowledge. The TOK and PTB show how the natural world is singular and monistic in the sense that the foundational ground of existence is an energy information field out of which the dimensions of behavioral complexity called matter, life, mind, and culture emerge. These latter three all give rise to complex adaptive dynamic systems whose patterns of behavior are not just matter and energy on a field of space and time, but include dynamically self-organizing complex adaptive systems that engage in information processing and communication behaviors that require different metaphysical concepts above and beyond efficient causation. That is, contrary to older reductionist notions long prevailing in the sciences, phenomenon at the levels of life, mind, and culture are emergent, exhibiting behavior inexplicable by a reductionistic analysis of material parts in isolation. These emergent planes are such because of the novel kinds of information processed at each successive level. As Henriques summarizes it, according to the TOK system, genetic information processing gives rise to the dimension of life, neuronal information processing gives rise to the dimension of mind, and symbolic information processing gives rise to the dimension of culture. More specifically, I will argue we can actually say that these are novel kinds of meaning that have emerged, since these are kinds of information that entities may process in the learning of knowledge that bears on their viability. Genetic meaning speaks a different language than neuronal meaning, which speaks a different language still from symbolic meaning. These novel information processing systems create unique adaptive contexts that must be navigated according to their own informational demands, such that meaningful information has new emergent properties at each new level. The Tree of Knowledge diagram maps these levels, showing the emergence of life from matter, mind from life, and culture from mind. Given these unique informational contexts, each level thus sees its own kind of system-environment couplings. The UTOK's Periodic Table of Behavior (PTB) chart provides a concise map of these increasingly complex kinds of entity-field relationships that arise within the different complexity planes of matter, life, mind, and culture. As Henriques summarizes it, the PTB affords us a new epistemological lens that creates an ontological taxonomy of entity-field relations across the levels and dimensions of analysis that make up the stratification of behavioral complexification in nature. They develop across material, biological, psychological, and cultural levels of complexity. Thus, we see that the entity-field relationship, unfolding through the four planes of complexification, can be identified as follows. 1. The object-field relationship of the matter plane. 2. The organism-ecology relationship of the life plane. 3. The animal-environment relationship of the mind plane. And 4. The person-society relationship of the culture plane. Each coupling, I posit, creates mutual information correlating system with environment. Because of that, each coupling represents unique demands on viability, and thus a domain where unique qualities of meaning manifest. In fact, each entity up the complexity stack must engage with all of the various behavioral contexts below it. That is, for example, humans must navigate their socio-ecological culture, yes, but also the ecologies of animals, the environments of organisms, the fields of objects, and all of the permutations of their interactions. A human must have meaningful relationships with all of these domains if they are to continue existing effectively in such a world. Such relationships are not meaningful only in the subjective ways, but rather in a manner that is intricately tied up with reality going all the way down to thermodynamic necessity. To misinterpret the meaning of a grizzly bear, animal environment, or E. coli bacteria, organism ecology, or a steep cliff, object field, is to face entropic annihilation. To say it again, meaning of this kind has causal power. To meaningfully know a thing is to integrate its information in an adaptive way. Meaning is what enhances viability at every level by informing the behavioral interventions needed for entities to thrive. Thus, the more complex an entity is, the more complex information it must process across the numerous planes of reality. While all semantic information does ultimately cash out at the thermodynamic level, there are, it must be repeatedly stressed, novel layers to meaning introduced as complexity unfolds. These novel layers emerge as more complex information is processed through the universal learning process, such that meaningful information gets generated differently as you move up the complexity stack, but accumulates in an accretive way. Meaning for cells is processed as genetic information, but meaning for an animal modifies mere genetic selection with an overlay of neuronally meaningful information processing. For humans, viability-enhancing meaning must be sought across both of these informational domains as well as through symbolic exchanges. Complexification and learning.